All right, we're going to do an oblique application or an oblique triangle word problem, if that's an easy way to think about it right here. And I'm only going to do one because these questions can be so varied, and you can use the law of sines, the law of cosines, the 180 rule, depending totally on what the question says and how you draw the picture out. Okay, and everybody might end up drawing the picture out completely wrong, and it'll lead you to do something else. But in our case, we're looking to see if can you solve your triangle correctly. Now, the idea behind an oblique application is that you're going to use some form of the law of sines, law of cosines, or 180 rule to solve this. So the idea is no right triangles. Now, I'm not saying that there isn't going to be aspects that won't be right triangles, but we'll see. So let's do this example, and hopefully you see how I go about it. So an aircraft tracking station determines the distances from a helicopter to two other aircraft, or 50 kilometers and 75 kilometers. So we're talking triangles, so I'm going to assume that I'm going to put a helicopter here, call that my helicopter, to some other aircraft is 50 kilometers, and then another aircraft is 75 kilometers. So it doesn't really matter what we call these. We call them A and B for that matter. Aircraft A, aircraft B. And the angle between these aircraft is 49 degrees. So 49 degrees. Determine the distance between the two aircraft. So we're looking for little h according to our triangle. That's how I read it. So again, determine from a helicopter to two other aircraft. One's 50, one's 75. The degrees between them is 49. The angle between these, determine the distance between. Okay, so yeah, we're looking for h. So according to what we learned with the law of sines and law of cosines, I don't have a corresponding side and angle. I can't use 180 rule. I'm stuck using the law of cosines. So the law of cosines in this case is going to be, I'm going to label this side little a and this little b. Is going to be h squared equals a squared plus b squared minus 2ab times the cos of angle h. I'm going to substitute all my values in. So a is 75 squared plus 50 squared minus 2 times 75 times 50 times the cos of 49. Nice thing, again, this one's looking for a side, which is awesome with the law of cosines because I know that I can just pump it all into my calculator. So I get h squared, I pump that in my calculator, and I get like 5,870.56. Now that's not the distance between the two aircrafts because that's h squared, so I got to square root that. And when I square root that, I get an answer of h equals 76.62 kilometers. So if you're the person running this air traffic station and you had to tell that helicopter or those aircraft how far they are apart from each other, that might be how you end up doing it. Okay, now hopefully you've got some sonar or something, but like I said, I could do 100 examples and they'd all be just oblique triangle questions. It's just a matter of you taking the words, applying it onto an oblique triangle, and then using what you know, law of sines, law of cosines. Okay, so try your best.